Hi, welcome back to Microsoft Virtualization with Hyper-V and System Center. Corey Hines, Simon Perriman, here to look at Module 8, which is Managing Infrastructure with System Center Virtual Machine Manager 2012 R2. This particular module deals with a lot of topics, primarily focused on how we manage the elements that make up our virtualization infrastructure. So that includes things like networking, it includes things like storage, how we deploy and manage updates, and also how we work with clusters in Virtual Machine Manager.
Excellent. So we're going to start by looking at our networking infrastructure. Now, yesterday, Corey and I, we spent some while talking about the basics of network virtualization.
Absolutely.
We're not necessarily going to repeat that. We'll just kind of give the quick overview in case there are some people that weren't able to attend yesterday. But this whole module, we're going to go demo heavy. Rather than really talk about how it works, let's just show you. Let's go create all these different networking components. So first of all, let's go through a summary. What can we do within our networking? Well, as we've talked about with infrastructure, we're kind of covering everything throughout the stack. And you'll see here on the right, under networking, we have quite a range of different networking components that are managed. Now, as we start to think about what is a private cloud, one of the key tenets is pooled resources. And what that essentially means is you're able to aggregate and manage all of your resources from a centralized location. Now, generally, storage is kind of the most commonly used example here, right? It's easier to kind of logically or conceptually understand pooled storage. You need storage. There's this big cloud of storage. You take some. But networking has a very similar concept. With our networking, we pool our networking resources as well. So if you have a variety of load balancers through the environment, we can go interact with them and go use them as we create new services, new applications. And we're also going to be creating a lot of network type templates that we can go deploy on our hosts that configures the networking on that host. Templates that we could use for VMs, templates that we can use for ports and different types of port classifications. So you're going to see us use these consistent private cloud best practices, concepts throughout all of our infrastructure. So not just our servers with memory and CPU, not just storage, but also networking. So what is our networking infrastructure here? It consists of a few components. We have our basic management systems. We have logical networks, IP address pools, load balancers, network virtualization. We're not going to go define all of these yet. We'll do that as we go through our demos. We also have the ability to go and configure different ports and different switches within VMM.
So one thing I just want to really quickly interject here. You're going to see a lot of these terms like logical switches, port profiles, uplink profiles, virtual switches. It's important that if you're going to work with VMM, you understand what these are. So take the time to learn what the definitions of these objects are. Otherwise, you're going to find yourself pretty confused down the road. So for example, know what a port profile is as opposed to an uplink profile. Know what the different types are. Know what a logical switch versus a virtual switch is. Again, it will help you to take the time to just understand the definitions that are used in the product.
Absolutely, and we're going to be going through these individually as well in a second. Now, next concept we want to bring up again is this concept of using virtual networks, network virtualization. Now, with virtual machine networks, these are built on top of our physical networks, our logical networks, and it essentially just abstracts and simplifies our networking. And what we're going to do is we're basically going to define what a network is. So you say we're going to create a logical network, and underneath that it's going to actually have your real subnets, your real sites, your real IP address pools. But the conceptual concept here with network virtualization is simplifying it. And basically what this means is when you've gone and created your new logical network, let's say it's called Contoso network, when you now go and deploy a new virtual machine, you just say, I want to go deploy it to Contoso network. And we actually figure out what that really means, where that VM should live, what it should be connected to, what virtual networks, what network adapters, what type of privileges, permissions it has, if there's any associated VLANs, and also what IP address it can use. That's part of that network.
You know, as you stop and start to plan an implementation of a network with Virtual Machine Manager, one of the most important steps that you can actually take is to diagram everything. To sit down and go, okay, here's the data center that I'm going to work in, here's all the subnets and here's the routers, and you draw a diagram. You see, okay, my data center, which is a big 10.xx subnet, that's going to be my data center subnet. And then I can use that to begin, as I build this diagram, defining the objects that are going to get created later. If you just jump into VMM and start creating stuff, you're going to get in trouble. You've got to take the time up front to diagram everything, draw it out, and sit down and plan it before you begin actually creating the objects in there. And where that starts to help you down the road is, as you define a new VM, as you were saying, as you define a new VM, when you create this network object called data center that represents, let's say, your core LAN in your data center, you call it, data center. You then go through all your hosts, and based on the IP addresses the host has, so you say, data center 10x subnet, every host that has a 10x IP address will associate itself with that object. So when you go to deploy a new VM later and you say this VM needs to talk to data center, it's going to look at all the hosts and it's going to say, okay, which hosts have associated themselves with data center, so they become candidates to host that VM. And the same is true for when you go to the next level of abstraction, virtual networks, right? And then as you take that even a step further, you say deploy to data center where there's a fast connection. And maybe you define fast connection as a 10 gigabit connection. So now all the hosts understand the definition of fast, understand it requires 10 gig, and if they have an adapter that's 10 gig on data center, they label it and they tag it that way. So you never have to worry about where something physically is. All you've got to do is define the properties of it, and VMM, by nature of looking at all the different physical elements, determines where things can live.
Great point. Now we're going to switch over to our demo and actually show this in action. So this is our VMM server. Now we're going to be working within the Fabric workspace once again because networking is considered part of our Fabric. If we minimize our servers, go and expand our networking, we could go see all of these different networking components. So let's actually spend a minute quickly kind of talk through what each of these items are. First thing we have is a logical network here. And a logical network, it's essentially a definition of the underlying physical networks. It kind of gives us an easy to use name so that when we say deploy to my network, we know that underlying topology. Next thing we have is what we call a MAC address pool. Now, MAC addresses are, what we can use to specifically identify virtual machines. As you remember from the lesson yesterday, Hyper-V virtual machines always start with a predefined prefix. VMware virtual machines always start with a predefined prefix. And so we could go, these are already built into Virtual Machine Manager, so you don't need to think about it. But if you want to go create a different MAC address pool, use your own, you have the ability to do that as well. Now, under load balancers, this gives us the ability to integrate either software-based load balancers or hardware-based load balancers. Now, out of the box, we support network load balancing. Network load balancing is a System Center Windows Server feature that provides a software-based load balancer. Though its features are somewhat limited, it has pretty limited load balancing capabilities. But if you have a third-party load balancer, you can go and add this, integrate this. And so we already have pre-built integration with F5, Citrix NetScaler, Big IP, so kind of a lot of the most commonly used ones in the industry. We can go add, start using
And
them.
certainly there's a provider model within VMM where if it's not there by default, but you work with a vendor that makes one, and they support VMM, it can be added in.
Absolutely. And one thing that we're seeing a lot of is network component virtualization as well. So in the past, where you might actually have to buy a physical device for your load balancer, we're now seeing these companies produce a software version that runs inside a VM. And the advantage of this is you can clone it, you can scale it, and there's no physical network cables that you're actually plugging into this load balancer. So what we would actually do if we wanted to go deploy NLB, it would go spin itself up inside a VM and configure those properties so that VM is basically the brain that does our load balancing mapping. If you want to go get, let's say, F5, you can have their physical device or go get their software-based one. If you get their software-based one, it still has all those features, all those logic, but you could go deploy multiple instances of this. Now, I'm not going to talk about licensing, that's a whole different story, but this gives you more flexibility if you're running with virtualized load balancers as well. The next component we have is what we call VIP templates or virtual IP address template. This is used whenever you have a load balancer because a load balancer uses what we call a virtual IP address as a single entry point, which will then go and fan out and connect to all the different nodes within that load balancing cluster. So let's say I want to go connect to App Controller. App Controller is behind NLB. I have multiple different servers because it's highly available through redundancy. That single virtual IP address is what I connect to. And what that will do is then route me to node 1, node 8, node 16, whichever backend node it is. But this virtual IP address is kind of our single entity that we can use to go and connect to. Now, our next component we have here is a logical switch. A logical switch is essentially a template for a switch, for a physical switch, and you can go apply this template on a host. So let's say you do some advanced configuration of a switch, want to go and push that onto a host, and then go copy that on 20, 50, 100 different hosts. You could essentially use this as a switch template to go deploy on top of a host. We then have port profiles. Port profiles are essentially ways that you can go and define and manage ports here. And we have a bunch of them that are kind of pre-configured, pre-built in. So you can see ports for your clusters, for SO, IOV, for your iSCSI traffic, for your live migration traffic.
The important thing to understand about these port profiles is they do nothing until you assign them to ports on hosts. So think of these as classifications, right? You don't want to, you don't want to, if you have 20 hosts that have 14 different brands of NICs, you don't want to have to worry about, finding hosts that have particular brands or link speeds. You could simply say, you know what, fast. And you go through and you tag every network adapter you want as fast. I think it's, what's it called in there, high performance? I can't quite read it from here. It's high performance, right? So you tag it high performance. And then any VM that you deploy to a high performance NIC or a high bandwidth adapter is going to look for one that's equally tagged. So this is just a starting point. You can delete them all and define your own. So it's just a good sort of reasonable starting point as to how you would tag different network adapters.
How about port classifications?
So port classifications kind of work the same way. When you tag, you can tag a couple of different things. You can tag network adapters and you can also tag switch ports. Port classifications are associated more with switch ports. If you open up the properties of one of those for a second, again, they're nothing but tags. They don't govern or control anything. They're just ways of identifying different objects in the infrastructure. And then as you deploy VMs and services, it looks for, essentially does a form of tag matching to make sure things land where they're supposed to. Now, the one thing that the port profiles do that the classifications don't, the profiles actually can govern elements of the VMs themselves. So the port profiles represent, kind of configurations of virtual machine network adapters. So they do a little bit more than just the port classifications. If you open up the properties of one of the port profiles in there, so that you can see you can actually govern things like bandwidth control, which is what you would find on a Hyper-V switch or Hyper-V network interface card. So when you assign one of these port profiles to say a VM, it can control elements of the VM, and then it'll look for the associated classification on the switch when deploying the VM to make sure the VM lands where it's allowed to land.
Great point. Now I'm going to show everybody a little trick here as well. This won't be on the exam, just a nice little trick. If you want to go and view the properties of something you've already created, you're actually going to notice that the View Script button is not available. And that's because you haven't made a change to it, so it's not actually viewing the underlying pieces. If you want to go and actually view that underlying script, just make a change like add a space, delete it. You can go back to View Script, and then you can actually go back and see the full script again. So even though this has been pre-created, if I wanted to go and clone this particular profile, View Script's disabled, just go make a change and it will re-enable it, so you can go and view that.
Now, not for nothing, but if I were studying for an exam on this, I'd want to know the difference between classifications and profiles and when I'd use each.
Do you mind going into that?
I thought we just did all.
Oh, okay. I thought you wanted to add on add something.
That's what we just did.
Great. So, final thing we're going to look at here is network services. Network service is essentially one of these third-party providers that we want to go and connect to. So this can be adding a new gateway, switch extension, top-of-rack switch, load balancer. So basically, any of these additional modules that can plug in to VMM, we could go use by adding this network service. So let's actually go and now start to go build up our fabric. We are going to go and create a few logical networks. Now, what I'm going to show you under the covers is what our physical network infrastructure is. And throughout the day, I'm going to go and show you kind of what is happening within Hyper-V after we make changes within Virtual Machine Manager so that you can logically understand what is happening under the covers. That'll help make learning about this a little easier. So in this case, we're going to go and create some of our networks, and let's just take a quick look at the settings for these virtual machines. We can currently see that we have two network adapters. One is CorpNet01, one is our storage network. And so basically all of this infrastructure, all these System Center components have a single kind of corporate network and then a separate storage network that they're using.
Now, the reason that they're using a storage network is because for the purpose of storage topology, they're using iSCSI. And so you've got a separate, TCP/IP segment representing iSCSI traffic so that you can have some shared storage elements in there.
That's right, yep. So here we go, and we're going to say we want to go create a new logical network. So we'll call this our Contoso network for Corp. And we have a few different ways that we want to go and implement this. Go create it with VLANs, private VLANs, or just a standard network. And we want to go and enable this checkbox here, which says allow new virtual machines to be created on this network to go use network virtualization. Here's where we'll actually go and add the underlying network sites. Now again, remember this logical network is essentially a template or a blueprint for what our underlying physical network looks like. So we could say which servers are going to be able to use this new network, and what are the associated or the underlying IP addresses or VLANs with this. So in this Corp network, everything is built on my 10 subnet. So I define that under the covers, it's going to run on my 10 subnet.
Now you're using CIDR notation for the subnet, correct? So
Yes.
Instead of typing a subnet mask, you're typing the number of bits that are involved
correct.
in the subnet. So the 24 would be your traditional Class C 255.255.255.0 subnet mask.
Yep.
So helps to know your subnetting, old school subnetting. If you don't know it, you're not an IT guy.
Good thing is, this is pretty much the only place you need to think about it. You go at it the first time, from now on you say deploy to this network, we go and find you an IP address with that.
I'm sorry, if you don't know how to subnet something by hand, I'm never buying you a beer.
So we'll click finish. We now have a job that runs. Everything looks good. We can close our job window. And now we see our first net. It looks like it's fully compliant. So now let's go create our second logical network for storage. Going through the same wizard, Contoso storage. Now in this case, this is a storage network, so we don't want to use this network for network virtualization. And the reason why we're trying to isolate our storage network from our main corporate network is just to make sure that storage traffic stays as storage traffic. It doesn't go and interfere with our general networking. We then go and add our site, select all host groups, and in this case we're going to enter our 20 subnet. Click finish. Our second logical network is created. So we basically now have these two networks that we've defined, and now we don't need to think about those underlying IP addresses again.
So so how do those networks get associated then with hosts? Because I know for a lot of people the conceptual stuff's fine, but at the end of the day, that represents something. I can go touch a cable. So how does that get associated with that cable I can go touch?
Great question. Let's actually go do that now.
Okay, absolutely.
Now we're going to just go do this on the single server, but we're going to have to go do this again a little later when we go create a cluster. But essentially what we've done now is we have these two logical networks. We have our host that we've added. What we are now able to do is actually go and connect this host to these new logical networks. So I'm here looking at the properties of this particular host. I see Ethernet adapter 1, which is my storage network. Look at that. We could say this host is now going to be connected, or this network adapter is going to be connected to this logical network.
So now when I define a new VM and I say this VM is on Contoso Corp, it's going to go look for hosts that have an adapter that has this association.
Absolutely.
What if I've got 650 billion hosts? Is there a way that VMM can do this kind of automatically for me at all?
With a script?
With a script, but there's also, if you get down to the settings, there's an auto-detect option in there. So as you add hosts,
I did not know that one.
it will auto-associate. If you hit the settings down there and then go under networking. No, hit cancel on that.
So let me just add my storage
you
network.
Go ahead and finish your stuff there.
Second storage network added. So we're going to connect storage to storage. Click OK. So now that host is connected to these two logical networks.
Absolutely. So you go under Settings, and then under, I'm trying to see your screen right there, under Systems, New, up under General, I think. There, General Network Settings. You can actually tell it to auto-create logical networks and associate hosts.
Very nice.
So as you add them, it'll actually create logical network objects representing the subnets it finds and give them some generic names you can go rename and auto-associate the adapters. So.
Very cool. I'm learning stuff as well. That's awesome. Right. So now we've gone and defined these logical networks here. We want to go and create what we call an IP address pool. Now, IP address pool is essentially a collection of IP addresses that will go and run on that particular network. And what this means is each time we go and provision a new virtual machine on that network, it will take a free IP address that's within that pool. So we're going to say this is corp IP pool, part of this logical network. We'll use this existing network site. So this was the underlying definition I made, saying it's going to be within this range of IP addresses. And then I get to actually specify this range. Now, our .1 is that's reserved for some of our servers and our DNS infrastructure. So we're going to start from 100, and let's just go to 125. And this will provide us with 26 free IP addresses that any new VM we deploy will go take one.
So this is like DHCP, but not DHCP.
Exactly, yeah.
So it's, when you go to define a new VM, you can say, give this VM a static IP address, and it will actually assign it a static IP address from this pool of static IP addresses. And it's similar. It's not DHCP, but conceptually it's kind of like that. VMM reserves a pool of static IPs and then assigns static IPs based on that pool so that you can map things to it and things remain consistent. And then as that VM is retired, the static IP goes back in the pool again.
And can be reused, absolutely. You get to also reserve IP addresses for load balancers or other infrastructure servers. So, you don't want to give it the IP address of like your DNS server, for example. We can specify default gateway here. So in this case, for our default gateway, we're going to go and do this for our corp network. We could go and add DNS server addresses. So this means that any VM, these are pre-configuring the network properties for any VM that's going to be deployed on this.
A lot like making a DHCP scope, really.
Kind of. Add our DNS suffix.
It isn't DHCP.
We can add a Win server if we wanted to, confirm the settings. Take a look at our script here. So it goes and gets new logical networks, creates them, deploys them. Finally, it sets our new IP address pool. So the subnet, the IP address start, IP address end, information about our default gateways. Click Finish. Job is created successfully. And now we can see that we have our IP address pool. I'm going to quickly do that again for storage so that when a VM needs an IP address on the storage network, we can get one.
So while you're kind of creating that, one of the questions that comes in is, why do we need a logical network? And the answer to that is when you need a logical network because when you start to define and deploy VMs, you don't pick the host. You don't pick the cluster necessarily. VMM incorporates intelligent placement, right? Intelligent placement looks at everything in the infrastructure, looks at what the VM or service requires, and is going to give you a recommendation on which host this will best run on. Which host, or for example, which cluster. Now, one of the things it needs to know is where those hosts and clusters are plugged in. Because if you deploy a service that needs to be able to talk to your internal SQL server, well, that's got to be on CorpNet. So it needs to know which servers are plugged into CorpNet and which are not. And the logical network is the link that provides that association. So you don't have to worry about, deploy to this host on the third NIC or the fourth NIC because that's where it's plugged in. The NICs are associated with this logical network. The VM requires the logical network. It's the thing that binds them together that allows that intelligent placement algorithm to work out where it can possibly work and where it can't.
Yeah, really the key point here when you're managing with VMM is you don't need to think about what server it runs on anymore. we want to do that logic for you. You just say, I need this VM that should run within these parameters. We will pick the best host for you. So don't really think about this VM has to live on this host anymore. Want it to be fluid, dynamic in this private cloud environment. So we've gone ahead and we've now created our logical networks. And you saw we assigned the logical network to our first server already.
Yep.
Next thing we're going to do here is we are going to go down and we'll take a quick look at creating a logical switch. Now again, our logical switch is essentially the template of a switch that we could go and apply to a different host here. So we're going to say this is vSwitch, Contoso vSwitch. We have the option of enabling SRIOV, single root IO virtualization. We also have some built-in extensions that we can go and add as part of this. So if we want to go and add our Microsoft Windows filtering platform or the NDIS capture extension, those come built in. If we had third-party extensions as well, so if you have like some type of packet sniffer, forwarding, other type of network component, you can go and add it as an extension. And essentially, this means that the virtual switch we create on the host will go be connected to that other networking component. We could go create uplinks.
Now, I was just kind of holding this page for just one second here. When you create a switch, now, first of all, the whole idea of the virtual switch is, if you watched me yesterday, I went through all my Hyper-V servers and I created switches and I picked network adapters. So I had to go through, and if you're watching real close, on one of them I had to do an IP config to see which actual physical adapter had the IP address I was looking for. So when I made the switch, I associated it with the right adapter. When you create a logical switch, you're using these characteristics, these port profiles, port classifications, so that you don't ever have to worry about having to pick the adapter. The underlying hosts, just like with the VMs, when you go create the logical switch, the underlying host, because we've associated certain network cards with certain logical networks and certain classifications, it's going to associate with the right physical adapter so the VMs can actually communicate. What you're picking here with the uplink mode is whether you need one network card or two. So if you choose that this is teamed, you can't create the switch unless there's two network cards that meet the requirements. And it'll fail otherwise. If you choose not teamed, you only need one.
Great point.
Right? So pretty important to make the right choice here.
Great point. Now, as we kind of go through here, one other consideration or one other ask that we get a lot is, why do we build templates for everything? Like, if you're going to deploy 50 hosts, what is the advantage of having some type of template, some standardization?
Well, the idea is you don't make mistakes, right? I'm not perfect. You're not perfect. Everybody makes mistakes. The idea of having a template is that you have a point to start where you don't have to recreate everything from scratch all over again. And what they provide in VMM are merely suggestions. There's like, okay, we've talked to 50 bazillion customers and they've all done these things kind of the same way. So this is the stuff they all kind of have. Yep. Big, small, medium, large, doesn't matter. This is all the kind of stuff they all sort of have. So it gives you a really good starting point.
We all make mistakes, right? This helps eliminate that human error by build it once correctly, use standardization. Now here's an option where we could go and add port classifications. And so essentially what this means is this will only get added to a host if this host has support for, let's say, live migration workload.
Right. And so this live migration workload is something you would tag a physical adapter on a host as.
That's right.
So when this switch goes out to be created, it's going to look for an adapter with that tag. And if it can't find one, it's going to throw an error and say, hey, I couldn't create it because the tags don't match. At which point you can then reevaluate whether you want to change the tagging or you need to tag an adapter, or maybe you thought it had an adapter, but it didn't.
Absolutely. So we are even building these best practices into our templates. So we'll throw errors if, we have a problem with this template. So let me go back. Good. It did not create the virtual port, so it just did not allow me to create that error, as you were mentioning. So we now created our virtual switches, our ports, and then the final thing we're going to do is go and create a virtual network. Now, this is where we are actually going to be moving into our VMs and services workspace. Our virtual network is not considered part of the fabric. It's considered part of our virtual machine and service management components. So doing a quick look of the VMs and services workspace. First of all, we have what we call tenants, a concept of a tenant. And you can kind of think of these as particular user roles. So we'll call this our end user role, profile, They're going to be a application administrator. Now, we'll go through these different user roles a little later, spend a little time on that.
So again, just like sort of maybe another way of thinking about this as well is if you look at a tenant, if I have multiple people that need to use VMM but only need to use a subset of the resources that VMM manages, the tenant is the object you can use to essentially assign permissions to subsets of resources.
That's right. Different actions, different resources, different
So for those of you
templates.
that do Active Directory, like an Active Directory group is an object that allows you to assign someone to a subset of resources. A tenant, conceptually, you can kind of think of it that way as well.
A cloud is going to be something we spend more time later as well, but this is a logical collection of resources, a collection of pooled resources. But here's where we're interested, our VM networks. And so these are going to be networks that our VMs can use to communicate with each other or with outside world. So let's go create our Contoso VMnet. And what we're going to do here is assign it to a logical network. So where is this virtual network going to live on? It's going to go live on our CorpNet, not live on our storage network.
Now, one thing that's just sort of very important for as he's doing this level of isolation, we talked about network virtualization yesterday. And so we talked about the concept that, you create a bubble of connectivity within your physical fabric, right? And so what you're doing here is creating this bubble of connectivity that's going to have its own IP ranges, its own isolation, and it's going to be routed using GRE across all the hosts. But it still has to be connected to some sort of physical cable somewhere to actually get the data back and forth. And so when you're associating with the other logical network, you're associating that bubble of connectivity with some physical cabling infrastructure. So there's a physical layer, and then there's this logical bubble of connectivity that can span multiple hosts, but still needs cables to route around, and that's how you indicate the cable system it's going to live on.
Great point, great point. Now, next thing that we are looking at, so after our isolation, we're going to say we want to use network virtualization. Go add a subnet. Click Next. Connectivity. It's saying that, hey, you've done network isolation, but you're missing a gateway. That might cause some problems so they can't connect. Confirm the settings. And we've gone and created our subnet. Now, what you may have noticed here is that my logical network is on the 10.10 range, and also the subnet's on the 10.10 range. So we're actually able to create subnets on top of logical networks with that kind of isolated set of network addresses.
That's where network virtualization comes in. It's the 10.10 subnet living within the 10.10 subnet.
Right. And we can have a 20.20 living within our 20.20 as well.
We can have 4 10.10 subnets living on the same 10.10 subnet because they're logically isolated with GRE.
All right. So this is our basic introduction to network virtualization and virtual machine networks. We're now going to switch back to our presentation and take a look at some of our storage capabilities.
So next lesson in this particular module deals with managing storage infrastructure. When we think of Virtual Machine Manager, VMs obviously come to mind. Hopefully at this stage, networking comes to mind. But in addition to that, it has rich storage management capabilities. And it can manage a lot of different storage devices. You can use it to manage scale-out file servers and scale-out file server clusters. So if you were watching yesterday and you saw me configure a scale-out file server using cluster tools, I had to manually assign permissions. If Virtual Machine Manager does that, it does all the work for you. You simply point to click and drag. It can also manage iSCSI SANs. It can manage Fiber Channel because Hyper-V has support for Fiber Channel now. So it can actually take care of activities on SANs that you would normally go into the SAN console to do, like creating LUNs, zoning, mapping LUNs to individual hosts, and doing all the work so that you plug in a raw SAN, it'll do all the work on the SAN, connect it to a host, and present a disk. And it'll do that over industry standard storage protocols like SMIS, for example. So we've taken a look at some of those elements in this module.
Thanks. So here's some of the best practices or planning considerations you're going to want to think about. First of all, use good storage, right? It's kind of intuitive. Make sure that it's redundant. Make sure it's highly available. So make sure that you're using RAID. As far as access to the storage, use MPIO, multipath IO. If your storage is network-based, meaning that you connect over Ethernet, such as iSCSI or Fiber Channel over Ethernet, make sure you use a NIC teaming on those adapters to have that redundant access to your storage. Because that's the kind of output port as opposed to using an HBA. So block storage. With block storage, we're going to look at Fiber Channel, virtual Fiber Channel, iSCSI adapters. With file-based storage, we can support SMB 3.0. So this is the new Windows file server, file shares, which support Hyper-V. And with this release, the 2012 R2, we can now even create file server clusters, which are going to go and use a scale-out file server and store the disk for our Hyper-V virtual machine on that back-end file server. Additionally, we support NFS within the context of using it for VMware. So VMware supports share-based access to its VHDX files over NFS, whereas we use SMB. And so we support the NFS protocol to ensure that we can go deploy VMs to ESX hosts, which are using NFS storage. So within Virtual Machine Manager, two different methods of creating SANs. We can use snapshot-based methods where we're essentially creating a snapshot within the LUN, or we could go and clone existing LUNs. Now, if you're going to use either of these technologies, it still needs to be supported by the SAN vendor. And so let's go over to our demo and actually see all of this in action. So we're going to go back to our Fabric workspace since we're managing our storage. We'll minimize networking, and we'll go and expand our storage node. Now, first thing we're going to look at here is what we call a classification and a pool. So what we're actually doing here is we're going to go and create some different storage classifications. And again, these are just containers. They don't really do anything, but it helps us really logically group these resources. So we're going to create a gold tier. And then we're going to go create a bronze tier. And essentially, as we go and add different types of storage resources, we'll assign it to one tier or to the other tier. Again, this just helps with our logical grouping. Now, next thing we're going to look at here, as we look at our different storage types, is we are going to go and add some different providers. So what is a provider? A provider is essentially something which offers storage. Could be a SAN, it could be a file server if you're using SMB, it could be an iSCSI target if you're using iSCSI. Now for this particular lab, we've set up an iSCSI target and we've set up a file share. So we're going to go and add both of these providers. So we launch our Add Storage Devices wizard, and this gives us the option of adding a Windows-based file server, a SAN or NAS device that uses SMIS, SAN device using SMP, or Fiber Channel. Now, first of all, let's go ahead and add our iSCSI target.
Before you kind of do that, just a little point on that. You have to make sure that the hardware you have supports this stuff, because where there's a lot of consistency in switch management protocols, there's a lot of consistency in baseboard management. The whole idea of SMIS, and these are newer standards and newer technologies. There is not as much consistency across different vendors. So you've really got to kind of make sure that, hey, you're planning on investing in XYZ SAN from some company. Can you manage it with Virtual Machine Manager over SMIS? Now, the sales guy will probably say, of course you can, because he wants to make a sale. Test it. That's my point. Just make sure you don't assume this stuff, get it in and test it.
Great point. What I'm going to show you now is we're going to go and add this iSCSI target. Before we do that, I kind of want to show you what we're looking at behind the scenes so you understand this logical connection. Now, in this particular lab, I have my iSCSI target running on my domain controller. Not a best practice. Definitely don't want to do this one in production. I also have my file server running on this. I see Corey cringing in the horror of doing my enterprise storage on my DC here. It's functional in the lab. We got to be highly scalable here. But what you see here is all of these iSCSI virtual disks. And so these are what I want to go and detect and make sure that I can go and manage from VMM. So I'll go up to VMM. We'll select our SAN, managed by our SMIS provider. And here's the two different protocols that we support, SIMXML and WMI. I'll be honest, I'm not really that familiar with SimXML. Are you familiar with that protocol?
With SMIS SimXML, that's the one. Yes and no. I don't know that I can do a horribly good explanation of it, but essentially they're just two protocols. Right? The WMI protocol is based on the Windows Management Instrumentation framework. The SimXML is more generic.
Okay.
Requires it uses a different port. It's not based on the underlying WebM technologies. It's a matter of, when you get something and you want to go manage it, you've just got to choose the protocol that's going to be supported. For the Windows iSCSI server, which is what you're using, you want to use the SMIS WMI because that's how it exposes all its functionality.
Great. So we're going to use it, as Corey mentioned, this is a Windows file server using WMI. We select our account to run it as. We'll click Next. And it's going to go contact DC01, our iSCSI target, and find all storage that can be managed by this SMIS WMI provider. And what we'll get back is that different list of iSCSI targets. So here is it's found the correct server, confirm. And look at this. Here is our list of all of our different iSCSI targets. So let's go ahead and select our 4 large disks here at the end. So FGH and I. And here is where we can go and add them to a classification. Now in this case, this is my iSCSI storage, which isn't particularly fast, so I'm going to go and add all of these to my bronze classification. Take a look at the script. Goes and configures everything for me. Click Finish. Close the jobs, and now we can see under Providers, I have my provider type. And then as I look at my different classifications and pools, once this refreshes, we'll then see all of our iSCSI targets appear under here.
So have you talked about classifications for storage at all, or is that coming down the road?
We talked about it briefly in their templates. Do you want to add to that?
Yeah, much like we did, port classifications for switches, storage classifications work in much the same way. When you deploy a VM, you never pick the specific SAN you want to put it on, or the specific. God Almighty, I'm having a hard time today. Location where it's going to go. What you do is instead choose the classifications. Now, I have a lot of people that ask, well, I want to be able to target very specific things when I do this, and you can be as granular about classifications as you want. You can go one-to-one with your classifications. You can have every single SAN can be classified as what it is, and let you choose what you want. Or you can say, you know what, I'm going to be a little more generic, and I don't care which iSCSI array it goes on, as long as it goes on an iSCSI array. So I have a class for that. Or I just want it on SSD, and I have a class for that. So you can be as granular or as generic as you want with these things. And that's the important bit to remember, that you're not, because you're using gold and bronze, that doesn't mean you're going to use gold and bronze. You can use whatever you want.
Absolutely.
And I have seen people that have done literally, they have a class called, Dell Ecologic, 51.4, rack 3, row 2. You can do that. That's fine.
So a lot of flexibility. What we're really trying to show you here are some recommendations for best practices, as well as show you the breadth of features, because, hey, it could be on the exam, right? Now, as we go back to the demo here, you can see that now as I take a look at my bronze, here we go. Our iSCSI targets are now available. We can see the underlying logical disks, logical units. So this is essentially, giving us access to go and now manage iSCSI targets through VMM. But we're going to go and add our second provider, which is going to be our SMB file server. So under here, I select a Windows-based file server. We go specify the actual path of this file server. So this is going to be on our domain controller again, not a best practice.
You just love putting stuff on domain controllers, don't you?
I do. Nothing happens on a DC. They're easy to manage. Just let it be fine.
You probably got 40 snapshots on it, don't you?
Yep. I certainly do. Actually, let's see, only like 10.
Simon Perryman, the antidote to data center availability.
Yeah, you can see I got about a dozen snapshots running on my DC now. Don't follow this best practice. So we'll go back to VMM here. Confirm that this is the file server I want to use. And then it will go and list all of the shares that are hosted on it. So in this case, I'm going to go and select this cluster share. So I'm going to go deploy some VMs on the CSV disk. We'll make this gold because it's SMB. Should be kind of fast. Click Next. Oh, actually, I didn't classify. Yeah, I did. Okay, add it under the gold. Click Next. Click Finish. We've set our file server. And now if I go take a look at the provider, we see the same server providing both our iSCSI as well as our Windows file server. I go back to my classifications. Once this refreshes, we'll then see the file server available under gold. So now that we've actually gone and created this storage, we can actually start to provision it. And so what I mean now is we have access to these different providers. We can now start carving out LUNs, carving out storage using these providers. So let's go ahead, excuse me, take a look at our array. This is our iSCSI array. And we get some information at the bottom here saying what disks are part of this array. What's the total capacity? What's the total usage? So some nice information to get us started. So we're going to go back to our storage. And we're now going to go and provision a LUN. So we could do this from our ribbon up at the top. Say create a new LUN. It gives us the option of our different iSCSI targets. So let's go ahead and create this on F. We can see that it's 70% pre-allocated already. And so we'll call this LUN 1. We'll give this, let's say, 20 gigs of RAM. Click OK. Oh, it's that simple. We've gone and provisioned a LUN. Now, the key thing here is that we're really abstracting storage management. That LUN could have been provisioned on Dell, EMC, Fujitsu, HP. It doesn't matter. It's provisioned the exact same way. And this is what's going to simplify our storage management. That consistency. Essentially, Virtual Machine Manager is a layer that sits on top of your storage. You tell VMM to do something, under the covers it will go translate those APIs for Dell, for EMC, for Equalogic, for whoever. Those are built in. And so this is what's going to help simplify management, save costs. And another benefit, it can help avoid vendor lock-in. You know, if you're unfamiliar with these other storage solutions, but you have financial issues, hey, you can go look at other vendors because you get to manage it consistently. You're not learning a brand new vendor management interface for storage.
Yeah, and the good thing is the guys that manage your virtualization infrastructure, they don't got to worry about the hardware now. They can deploy things and let the hardware guys worry about the hardware. Because as you get into these more complex SAN implementations, there's specific training you go take. There's a lot you've got to know to do these things well. These are complex pieces of equipment. So certainly anything you can do to abstract that from the guys that just need to do a job, deploy VMs and storage and whatnot, is absolutely beneficial.
Great point. So we've gone ahead and we just created 3 LUNs that they're going to get provisioned so that we can start to access them shortly. So this gives us all of our LUNs. Now, next thing we're going to do here is go and create some file shares. So we've provisioned iSCSI storage from our iSCSI array. Now let's go take a look at our file server and go and create some file shares. So it's going to give us the option of which file server do you want to use. And so we're going to call this VM Share 1. Put this under gold. It's going to use SMB. Then we could even go create a new local path. So we're going to go create this under C, shares, VM Share 1. Take a look at the script. Get our storage server information. Add it to the classification. Create this new file share. Click Create. Our first VM file share is being created. Let's do that again for our second one. Add it under gold. C shares VM share 2. Click Create. Now as I go take a look at our classifications under gold, once it refreshes, we'll go see these file shares. So they'll be available very shortly. Now, final thing we're going to do here is we're going to go and take a look at our host reserves. So what we're trying to do here is reserve some fixed properties for all of the hosts within our host group. And so this is essentially saying that we don't want a particular host, the physical server, to use more than 90% of its CPU. So essentially we're saying we want to reserve 10% of the CPU for that host. And again, this is for the parent partition. This is what actually runs the host operating system, manages the hypervisor, and the interconnection to any VMs. Now in this particular case, I'm running VMs. They have a bit of memory, 16 gigs, but I'm just going to kind of bump down the host reserve a little smaller. This is going to allow us to deploy more VMs on top of it. And we're going to say that we want to make sure we reserve at least 10% of our disk space.
Is there a recommendation for host reserve for memory?
I've heard 10 to 20% is kind of a standard. Do you have a recommendation what you use?
Well, my recommendation is 10%. That's typically what I see and what I try to use. But it depends on what you're doing on the host. For example, if you've got ops manager agents and you've got a config manager agent and you've got a DPM agent, they all consume memory. And that 10% might not be enough if the host only has 64 gigs of RAM. That's only 6 gigs. That might not be enough to do all that. You just kind of got to monitor it. But if your hosts are a terabyte, 10% is 100 gigs. That's probably more than sufficient to run the ops manager agent.
Yep.
One would hope.
Hope so.
So at that point, 1% might be adequate. So, and you've also got to factor in how many VMs you're running on the host. The more VMs you run, every VM's got a little bit of management overhead. So, there is no right or wrong answer, but, my rule of thumb is I start with 10% and I kind of work from there.
Okay, good point, good point. Now, as we continue to look at some of these host properties, next thing we're going to take a look at is networks. And look at this, IP address pools, they've been assigned to these different networks. Our logical networks assigned to the host group. Our logical networks have been assigned to the host group. And we're going to be continuing to use our default MAC address pools. Now, next thing we want to do, though, is we've just gone and created these LUNs. Let's make sure that these LUNs are going to be available for these hosts as well. So as we kind of take a step back and think about these different pieces, we've gone and created a host group. We've added some servers to that host group. We've gone and created added some storage management servers. We've gone and created storage. Now we're basically going to attach the storage we've created to this host group we've created so that anything that's part of this host group can now go and use these new LUNs. So here I say allocate a LUN. And look at this. It gives me the option of these 3 LUNs that I've just created. We'll go add them to these host groups. And now any server that's part of that host group has access to this shared iSCSI storage. Click OK. And now we've gone and added this to our LUNs. So this is our quick overview of storage management.
And so the next piece that we're going to take a look at here before we move on to clustering is infrastructure updates. And we've actually had a couple of questions that have been coming in over the course of while you were doing that on the chat about how do I patch and how do I do this, and that's what we're going to cover in here. Before we do, there's a couple of quick things from the Q&A chat I thought we'd just quickly bring up. And 2 of them are people asking how stuff relates back to what VMware does. So, and I thought I'd toss these out, and I don't know if you know the answer or not, but pools and data stores. Are they equivalent or close to it?
They're similar. One of the concepts that we have within Windows Server 2012 and onwards is this concept of storage spaces. And a storage space is essentially a collection of underlying storage. It could be a bunch of individual JBOD disks. It could be iSCSI targets. It's basically a logical container for storage. And we call this storage space. It's conceptually similar to what we have with a storage pool, though.
Okay. How about a logical switch and a VMware distributed switch?
Good question. So what's the difference between our logical switch and the VMware distributed switch? This is it's the functional equivalent. So to clarify here, the VMware distributed switch, the nice thing about this is you could go create it, and as you go add new servers, it's going to automatically scale. And that distributed switch essentially goes and spans your different ESX hosts. What we're doing with the logical switches is basically the same concept. It gives you that template that you're going to apply. Kind of the difference is we have to actually go and then apply that template across the different hosts. So conceptually the same. The way you would actually go and deploy it, go and implement it varies slightly.
So same result, different procedure.
Yep.
Okay. And then someone had asked a question about, and I realize we're doing a little bit of switching, but I wanted to, before we get too far ahead of this, logical switches and teaming and kind of what goes on there. And so what happens there is if you create a logical switch, and you just define that logical switch requires team network adapters, it's going to go into the Windows Server 2012 host running Hyper-V and create the team there with the teaming that's integrated in the operating system. So before it puts the switch, or as part of putting the switch on the host, it'll identify the network adapters based on logical network association, create the team. Once the team is created, create the switch and bind the switch to the teamed interface. So I just kind of wanted to address those before we move forward into infrastructure updates.
Great point. All right, well, let's move on with our infrastructure updates now. So what are infrastructure updates? Basically, Virtual Machine Manager has the capability to do patching on its infrastructure servers. And so going back to our demo system here, what we mean by infrastructure servers is our all hosts group, so the different Hyper-V hosts that we can manage, and then the things which we list under infrastructure, with one exception. So we can patch our library servers. We can patch our Pixie servers. We can patch our update servers. We can patch our VMM server. We cannot patch vCenter servers, okay? VMware, they have a different patching technology. You need to go and patch those hosts through that. So you can't use Virtual Machine Manager update management for vCenter servers, but anything else within the infrastructure, you can patch. So what we actually look at now with infrastructure is we can go and integrate with Windows Server Update services. Now, first question that's going to come out is, what about Configuration Manager? Hold up on that. We'll cover integration with Configuration Manager shortly. What we're essentially doing with Windows Server Update services is using that to go and collect baselines, to go understand what patches we want to go and apply to our infrastructure. And so as we go use this, it goes through the same procedure that cluster-aware updating uses that we discussed yesterday. Once it's turned on and you create what we call the baseline, which is a collection of patches, we go and assign the baseline to a host group or to a cluster or to a specific VM. And it goes and scans that group or that cluster and analyzes what patches are needed, what are missing. It's then going to go pick one server, and it will always do one at a time. And it goes through the same process of, if it's a cluster, it will pause the node. This basically means that nothing can move onto it. And at the same time, it's going to be drained. So all the VMs will live migrate off it. It will patch it. It will go through those same 3 checks. Does the VM get rebooted and come back online? Is the patch installation code successful? And if it's part of a cluster, does it rejoin the cluster? If that's successful, it will then move on, take it out of maintenance. So unpause it. If things are enabled to fail back, they will fail back. If not, they'll stay where they are. Take the next node and kind of repeat and go through this end-to-end cycle here. If it does hit a bad patch, both cluster-aware updating and update management, the process will stop. It will raise an alert and get admin intervention. And the reason for that is we don't want to go and apply a bad patch on every node in a cluster and take down your entire infrastructure. So as soon as we hit an error, we're going to pause and give you kind of a chance to go and figure out what the issue is. Now, as you're thinking about an update baseline, you're essentially thinking of a collection of updates assigned to a specific server. And you might have different patches that you need for different types of servers. Your file server cluster is probably going to need different patches than your Hyper-V cluster. So you can have this granularity to assign different baselines to different host groups, different sets of VMs. So what about Configuration Manager? What about Windows Update? We do have a dependency on Windows Server Update services, but Windows Server Update services itself can be integrated with Windows Update or with Configuration Manager to kind of provide this end-to-end mapping. So if you only have Windows Update and you're interacting with Windows Server Update services, WSUS will pull down the patches and allow you to go and manage that based on how you define the patches in WSUS. If you want to use Configuration Manager instead of Windows Update, you can. Configuration Manager needs to be managing that particular WSUS service, and we still interact with that WSUS service as an intermediary. So one more time, there's no direct connection between VMM and Configuration Manager. It has to use a WSUS server as the intermediary, which is managed by Config Manager. So what you would do is, Config Manager, you would go define your patches, define your baselines, make sure that you have a managed WSUS server that contains those baselines. Then within VMM, you go and speak to that WSUS server, take down the patches, the baselines that you need.
Now, in terms of just kind of following on the patching, a couple of quick questions came through. Is what does VMM directly do to make sure that, as you're applying the patches, you only get the patches you want on, for example, your Hyper-V clusters? Because, at the end of the day, what you might approve for all your servers, you might want to be a little more stingy on some of your clusters. I know with our clusters, we're very picky over the patches we put on because we don't want to introduce variable. We know it works. Yep. We don't want, a patch is a change. We want to minimize change. Can you approve things in WSUS and then do a subset in VMM?
So the best way to logically organize that is you would go create these different baselines for those different groups of servers you need. So you create the one baseline for your Hyper-V clusters, one baseline for everything else, or general patches, let's say. When you actually go through the compliance, you actually can do a compliance scan before you actually go and apply those patches. And what that will do is you can pick a particular host group. So maybe you have your host group for the cluster, or pick a particular cluster or a particular server, run the compliance scan, and before you even start a patching cycle, it will tell you what you do need or what you don't need. So in the case of your scenario here, you would probably either pick that particular cluster, or if you have your clusters organized in a host group, you'd pick that host group, you do the compliance scan, figure out what you need, and only apply the patches from that particular baseline.
Absolutely. Excellent. Thank you. Good answer. All right, so we're going to move on to our final lesson of this module, which deals with Hyper-V clustering. And some really, really cool things in here. So we did an entire module on clustering for Hyper-V yesterday at the end of the day.
Yep.
So I don't think we're going to be getting too deep into how you build a cluster, for example. More, how does VMM manage a cluster? And there's two really, really cool things it does. One of them is a dynamic optimization, which allows you to balance load across cluster nodes and allow VMM to, live migrate things back and forth, depending on, this one's heavy on CPU and these two are not, and it can balance the VMs around. And then something I really dig, which is power optimization that takes into consideration not only, where things are balanced, but are you using all your available compute power, or do you only need a fraction of it, and can I turn things off? And that goes back to some of the host management stuff you were using earlier with BMCs to enable that scenario to happen.
Yeah, we're going to take a quick look at that. Unfortunately, we don't have a power management demo, but we will kind of discuss how to configure it in the different options.
If I pull a plug and kill the lights,
that's the demo.
Fair enough. All right.
So quickly reviewing what's been added with failover clustering in 2012 R2 and 2012, support of 64 servers, 8,000 VMs. Shame on us, we didn't update the slide on either day. That should be 8,000 VMs we're supporting here.
We've bumped it 2,000 since yesterday.
Yeah, a lot of improvements overnight. And of course, within our cluster nodes, we go and require the shared storage so that we have that single consistent source of our application data. Now, dynamic optimization, this is basically a simple load balancing algorithm. Based on a couple different resources that you could set. So this could be based on your memory, your CPU, your network I/O, or your disk I/O. And what dynamic optimization will do is try to constantly load balance your VMs if they pass a particular custom-defined threshold. So let's say this threshold is memory utilization is above 70% on this host. We're going to go detect this as a problem, and we're going to go live migrate to help distribute the load across those different hosts. But now that we've distributed it, we've got a second alert. We passed our optimization threshold again. We're going to go distribute it once again. And hopefully this is going to give us the ability to constantly be moving these virtual machines around using live migration to ensure that we keep our hosts healthy and they have additional reserve capacity. Let's say, for example, in case a cluster node crashes and we need to take on additional VMs. Now, power optimization is a similar concept, and power optimization actually has a dependency on dynamic optimization. You cannot use power optimization without dynamic optimization. So that could be an exam question. Why is power optimization not enabled, not possible? Because you need to turn on dynamic optimization first. Now, with power optimization, we're essentially looking for minimum thresholds. And if a host is going below a minimum amount of required resources, we could go put it to sleep so that we're not actually consuming power. And so we go and interact with this using that baseboard management controller again to basically say, hey, you're going down. This particular host isn't really needed. let's go and live migrate our VMs off it, and we'll just turn off the host overnight. Now, we are cluster aware. We are quorum aware, so we will maintain your cluster quorum. As soon as we need that host again, because resource utilization starts to peak, maybe 8 a.m. in the morning when people are starting to come back into work, we can turn that host back on and start going and load balancing back to that host. So let's go ahead back to our demo and take a look at our cluster management. Now, first thing I'm going to show you is just a quick under the covers view of what we're actually going to be adding. So here is Failover Cluster Manager. I have a basic cluster, nothing on it, 2 nodes, and no storage. So this is just literally a 2-node cluster. Now, you will also have the option of actually creating a cluster through Hyper-V Manager if you want, if you have 2 or more hosts. Now, just to save time with the demo, I pre-created this cluster, and we're just going to go and add it under management. So we go and add resources, Hyper-V hosts or clusters. They're in our trusted domain. We specify our run as account. And then in this case, we're going to go and actually specify the computers by name. Last time you saw us generate an AD query. And in this case, I don't even need to know the names of the node. I can just go specify the name of my cluster. So we'll say cluster Hyper-V. Oh.
Now, folks, when you do this, it does say on the screen, put them on a separate line if you're doing more than one. I've seen lots of people try to do them all on the same line.
Good point. Good point there.
It's a silly thing, but it's one of those things where people just get annoyed and get frustrated. So.
Now here's our computers, or the cluster that it discovered, and shows me the nodes that are part of that cluster. We've already got our hypervisor enabled. We then figure out, where's this going to be running? We'll just put this in our primary site again. We can view the script, add SCVMM cluster, name, etc. Click Finish. And we're now going to go and add this cluster under VMM management. We see us add in the first host. Down here under the details, you can see the specific steps that are going on. And once this has been created, we are then going to go and actually refresh it to make sure that the virtual machine manager host can see it in its current state, that it's online and responsive. Now, while we wait for this to finish, any other questions that have come up here?
There were 2 ones that came in I wanted to get you addressed, which was dynamic optimization versus DRS.
Good question.
And that came up before the slide came up and said, yes, they are roughly equal.
That is correct. So comparing our technologies here. So dynamic optimization from Microsoft, DRS, or distributed resource scheduling from VMware. Functionally equivalent, do pretty much the same thing. They're going to do this distribution, load balancing across your different hosts.
And then which resources does it actually monitor to make the decisions?
So I can't give you the correct answer for DRS, but for dynamic optimization, it's going to give you network I/O, storage I/O, CPU, as well as memory.
And then you define thresholds that represent too much.
That's right, yep.
And then once something exceeds too much, it will run a dynamic optimization cycle and rebalance everything.
Absolutely. That goes and creates triggers. So one other consideration or question we get asked a lot is, if you're managing a VMware environment, so you have a vCenter server, you're managing that, and you have DRS turned on, would you also use dynamic optimization or not? So let me actually take a step back. What we are doing within Virtual Machine Manager for VMware management is we are doing day-to-day operations. So some of the initial configuration you might need to do through VMware, like setting up your distributed vSwitches and ports, you actually still need to use vCenter for. But the 90%, 95% of day-to-day operations, you can just use VMM. And that also includes our dynamic optimization. We can go and monitor those ESXi hosts, look at the traffic, and do load balancing by using vMotions through those hosts. Same thing on a Citrix Xen server. We can do dynamic optimization on that. However, if you have DRS turned on, you should use either DRS or you should use dynamic optimization. Don't do both at the same time, or this could cause some conflict because these 2 systems don't communicate with each other. Now, another question that always comes up since we're spending a minute on VMware is dependency on vCenter server. Now, if you're managing a Citrix environment, you can manage the Xen servers directly. Do a Xen motion, and you don't actually need Xen Center there. You can have it if you want. One challenge with managing a VMware environment is it does have a dependency on a vCenter server. And the reason for this is the individual ESXi hosts, which are the VMware virtualization hosts, they don't have an open API. So this means VMM cannot tell the host, go to a vMotion. What we need to do is use vCenter as an intermediary. So VMM tells vCenter, go do a vMotion. vCenter then tells that individual host or host pair, go do that vMotion. So again, with VMM management, you do require vCenter. With Citrix management, you do not require XenCenter. All right, back to the demo there. That was a very long answer and answered a lot of additional questions, but hopefully that gives a quick overview of that management. Now what we have here is our Hyper-V cluster. It has been successfully added. We can see that we have some available memory, some issues with this one, so we'll just do a quick refresh. Make sure that that guy gets healthy. Now in the meantime, we are going to go and take a look at the properties of this cluster. So here you can go and configure reserves for the cluster. And so this is basically saying how many nodes do you want to guarantee stay online. And this is going to be tied in if you're doing things such as power optimization, making sure you don't turn off too many hosts. You can then take a look at the status of the cluster. We can see that the cluster service is running, the nodes are online, but look at that, my cluster validation has not been run. Not good. Let me go back and we'll go actually validate our cluster, just one button. Now, for the sake of time, we're not actually going to go review a new validation report. We did that yesterday, but it goes and triggers that exact same validation test directly on the cluster. Go back to our properties here. Now, once that validation test is run, you're actually going to see a direct hyperlink to show that validation test. So let's go and take a look at our our available storage here. Now, again, if we go back to Failover Cluster Manager, remember we don't have any storage assigned to this cluster. But yet, we've provisioned some storage and assigned it to this host group. Remember, we just created those iSCSI LUNs. Let's go and make them part of our cluster. LUN 1, LUN 2, and LUN 3. So now our cluster can actually go and deploy VMs to these different LUNs.
So when you do this, this is going to trigger legitimate actions on those hosts, in that it's going to go touch those hosts in the operating system and map the iSCSI storage for you.
Correct. This does turns on the iSCSI initiator if it's not on already, connects to the iSCSI target, allows the target to accept that initiation request so that they can see each other and start communicating with each other. But you also get some nice some file provisioning features as well here. So remember, this is a brand new LUN using raw storage. Let's go ahead, quick format it. And so we're basically going to say bronze storage, NTFS, or do not format. Give it some labels. These are going to be our cluster shared volume disks, and force the format. Added. That quick. Now we're also going to go and add some file share storage. Actually, first, let's go and create some cluster shared volumes. Now remember, cluster shared volumes are this distributed access file system for Hyper-V, equivalent to VMFS from VMware. Now remember, we just gone and created these LUNs, but we're going to now take these disks that are available storage and turn them into CSV disks. So we'll refresh the view. This might take a minute to load because we're also running the cluster validation test in the background, so that'll be a little slow, but that'll show up in a minute here. Let's go and add our CSV disks. Go and take this LUN, CSV3, quick format. All right, so we've now gone and taken another LUN, made it into a CSV disk. Now for our existing disk that we've added, so this is available storage, we can see they're managed, and in a minute, once they get added to the cluster, we'll convert them to CSV as well. Now, final thing here we're going to add is file share storage. And this is going to go and connect to that file server we have. We just created those two file shares, share 1, share 2.
And this will actually add the permissions in the file shares as well.
It will. So we'll go add our cluster share that was pre-created for us, goal classification, SMB share, share 1, and share 2. So now our cluster can use the newly created shares. So as we kind of, go through this, to quickly summarize what we've done with our cluster, we've gone and added it under management, and then we've assigned storage to it, so that as we start to deploy virtual machines or other resources on that cluster, we can actually start to use those different cluster disks. Click OK. We'll save that. Now, final thing we're going to show in this module is the dynamic optimization and the power optimization. Now, these do not require clusters, though there's definitely a lot of benefits if you're using clustering with it, because we maintain quorum, we maintain the state of these different hosts. So as I go take a look at dynamic optimization settings here, first thing that we see is this concept called aggressiveness. Now, the terminology is a little pointed, I think, but basically what this means is frequency to load balance. Now, when you think about what happens when you do a live migration, the system is changing. We're copying memory, we're passing that memory through the network, and so that causes CPU cycles, network traffic, and host to change memory state. So the more live migrations you do, the more network traffic you're going to get. However, the more balanced your individual hosts will be. So if you want all of your hosts running at, let's say, 50% capacity, you'd be highly aggressive. If you're fine with some hosts running at, say, 30% capacity, some hosts running at 70% capacity, still somewhat balanced, you can set it to low, there'll be less migrations. Now with this timing option, you get to do the frequency that you're going to check for compliance and do load balancing. And under here are the 4 different thresholds that you can set. So go set different thresholds for CPU. So set a minimum threshold for how much, what's the maximum memory running on a host before we go and trigger a dynamic optimization. Configure disk I/O. Configure network I/O. Now, as soon as we go and turn on dynamic optimization, you'll notice that this button down here for power optimization gets enabled. Again, power optimization is dependent on using dynamic optimization. As we take a look at our power optimization settings, we get to set these power thresholds. What's the minimum? So if my computer is using, let's say, less than 1 megabyte of memory, we can go turn it off. But it's important to be able to schedule this as well. Maybe your business doesn't really do anything on weekends, so you can power optimization on the weekend is a good time for you. Maybe you're kind of a 9-to-5 business, so you can do it weekdays as well. And, you have this granularity, this flexibility to go and configure these different power schedules.
It kind of looks like an 8-bit coloring book.
Kind of. And so as we go and wrap this up, we've gone through our basic cluster management features. It told me that this warning level is too low, but I actually set for my dynamic optimization. It can't be less than 1 megabyte, so we have to go with 1024 here, which is exactly 1 megabyte. 1025, okay. Now, anyway, let's. Why don't we wrap up this module here?
Absolutely. So this has been obviously a pretty in-depth module. We've covered a lot of different things dealing with how we manage the fabric, storage, networking, and in addition to all those different pieces that relate in between, how we do updates, and also how we manage clustering at the end of the day. So a lot of material to cover here, giving you, we haven't even deployed a VM yet, and we spent almost an entire morning in Virtual Machine Manager. So before we wrap up, I wanted to address one kind of minor question that's come up a good 30 times.
Okay.
And that is, can we go to the widescreen shot for a second? People want to know what this is. This is a Surface, okay? You may have heard of them. This is a Surface 2. I can prove it because I can do that.
Nice. Drop it down.
And I'm running Windows 8.1. And there's been an entire litany of questions that's popped up as to, what's the tablet Corey's using? I want one. Can I buy one? Yes, you can. It's a Surface.
I think I may have seen a TV commercial about that once or twice.
This happens to be a Surface Pro 2. My Surface RT is over there on the floor charging. And I happen to like them. I actually quite like my Surface RT. Movies in the airplane, reading books, kids watch stuff on it.
Break dancing on a table, click. Doing that part?
No.
Okay.
I can't believe you just did that. That was the most ungraceful thing I've ever seen. So with that, we'll take a break for lunch. We'll see you. No, not lunch.
No, we're going to do a 10-minute break, and we'll be right back.
10-minute break.